Dear students, in this video we can see some sample AI problems and their state space representation. You are already familiar with the definition of AI, different areas of AI research and some important definitions that are related to artificial intelligence like intelligence, knowledge, belief and hypothesis. Next we can see what is heuristic knowledge. This is a very important definition. A heuristic knowledge means it is a special type of knowledge used by humans to solve complex problems. They are knowledge used to make good judgments or strategies or tricks or rules of thumb used to simplify solution of problems. Heuristics are usually acquired with much experience. That means heuristic knowledge is a special type of knowledge which we commonly employ for solving complex problems. For example, suppose you want to reach a particular location. You may be knowing some path or the way that you have to follow to reach your destination. But after going to that place many times, you may find some shortcuts to your destination. So that shortcuts that you will use or that you will know because of your experience can be called as heuristic knowledge. That is, to solve some complex problems, we may use some tricks or the tricks that we use to arrive at solutions easily can be called heuristic knowledge. And we humans have the habit of using heuristic knowledge, so that can be used in the case of machines also. Machines also can use heuristic knowledge to solve complex problems. It can be in any different form. We will study more about heuristic knowledge later when we solve some AI problems. Now we can see some sample AI problems with the help of which we can understand nature of AI problems. Three important AI problems are Waterjig problem, chess and 8 puzzle. If you consider any AI problem, we can find that every AI problem is having an initial state, a goal state and a number of intermediate states. And solving an AI problem means finding a path from initial state to the goal state, or it tells solution tells how to reach from the initial state to the goal state. So for AI problems, we don't have a fixed procedure to reach the goal state. We will start from the initial state and every step we will check whether we have reached the goal state. If not, we will continue. When we reach the goal state, we will stop. In the case of 8 puzzle, 8 puzzle means it is an AI problem. It can be considered as an AI problem in which we are having a rectangular frame having 8 different square tiles. These square tiles are numbered from 1 to 8. There is an empty square tile which permits movement of square tiles. A square tile can be moved either in the left direction or the right direction or up and downwards. Only movements in the left to the left or right hand side, upside and downside movements are permitted. Initial state can be anything and goal state is specified here. So from any start state you should be able to goal state by moving the square tiles in the permitted directions. Chess is another AI problem. You know the initial state of a chessboard. That will be the initial state. Goal state means any board position in which your opponent does not have any legal move. In the case of chess game, there is only one initial state, but there can be many goal states. Now we can see what is an AI technique. AI technique is a method that exploits knowledge. Knowledge should be represented in such a way that knowledge captures generalization. As far as possible, we should represent knowledge in a general manner. It can be understood. Knowledge should be represented in such a way that it can be understood by people who provide it. And we should be able to easily modify the knowledge to correct errors and to reflect changes in the world. Knowledge is something that constantly changes. So whenever some changes happens, we should be able to modify it easily, and it should always reflect the true knowledge in the real world, or changes in the real world. Here we can find some less desirable properties of knowledge. They are: knowledge is voluminous, it is hard to characterize accurately, knowledge is something that constantly changes, and it differs from data by the way it is organized and the way it will be used. In the case of data, we will be organizing in a manner such that it can be used easily. But in the case of knowledge, the way we organize data and the way we use it are different. Three important AI techniques are there. They are search, use of knowledge, and abstraction. For solving a particular AI problem, we may be using one or more techniques. Search is an AI technique which is used when we want to solve problems for which no direct solution is available. Use of knowledge is another AI technique which provides a way of solving complex problems by exploiting the structure of objects that are involved. Abstraction is an AI technique that provides a way of separating important features and variations from many unimportant ones. When we see some AI problems, we can study in detail about these AI techniques. To build an AI system to solve a particular problem, we have to do four things. First, we have to define the problem clearly. That is, we have to define what is its initial state, intermediate states, and goal states. Then analyze the problem. Third step is isolate and represent the task knowledge that is necessary to solve the problem. That is, we have to specify permitted operations. Fourth step is choose the best problem solving technique and apply it to the particular problem. Just now we have seen that three important AI techniques are there. We have to select the best possible technique for solving the particular problem. To provide a formal description of the problem, we have to do four things. Define a state space that contains all possible configurations of the relevant objects. Then specify one or more initial states from where problem solving process may start. Then specify one or more goal states that would be acceptable as solutions to the problem. Then specify a set of rules that describe actions or operations that can be done. We can learn all these things with the help of an example. First, we can consider water jet problem. Water jet problem is defined in this way. You will be given two jugs and a pump. In these two jugs, one is a 4-gallon one and the other is a 3-gallon one. There are no measuring markers on these jugs. You have to fill these jugs with the help of the pump. Using this pump, you can fill the jugs with water. You can pour water from one jug to another. You can pour water from the jug onto the ground. These are some permitted operations. Three permitted operations are there. The problem says how to get exactly 2 gallons of water into 4-gallon jug. As you know that we don't have any measuring markers on the jug, so it is not very easy to get exactly 2 gallons of water in 4-gallon jug. So if you want to solve this AI problem, first you have to know how to represent this problem so that machine can understand it. Using some kind of mathematical notations, you have to represent the problem. A set of ordered pairs of integers can be used for representing different states of the problem. Suppose we are having an ordered pair x comma y. X represents number of gallons of water in 4-gallon jug and y represents number of gallons of water in 3-gallon jug. X can take different values like 0, 1, 2, 3, 4. Y can take 0, 1, 2, 3. X is equal to 0 means 4-gallon jug is empty. X is equal to 4 means 4-gallon jug is full and it is having 4 gallons of water. For water jet problem, initial state is 0, 0 and goal state is 2n. N can be any value between 0 and 3. Here you can see some rules of water jet problem. You can read and understand it. 12 rules are there and they are called production rules for water jet problem. So here for every rule there is a left hand side and right hand side. Left hand side of the rule determines applicability of the rule. If the current state matches with left hand side of the rule can be applied. If the rule is applied, what state we will reach, that is specified in the right hand side. After applying the rule, we will check whether we have reached the goal state. If yes, we will stop. Otherwise, we will continue with the next matching rule. That is the idea of solving water jet problem with the help of production rules. Here I have written the rules in a simplified manner. Here you can see a solution for the water jet problem. The rules which I have applied here are Rule 9, Rule 2, 9, 2, 7, 5, 9 or 11. This is one solution for water jet problem. Here you can find another solution. We will stop when we reach the state 2n. In the first solution, our goal state is 2, 0. In the second solution, goal state is 2, 3. It can be 2, 1 or 2, 2. That is also a permitted goal state or a valid goal state. After getting idea about different states, with the help of that we can draw a tree like this, and this tree representation is called state space representation of water jet problem. Here you can see a two-level search space representation of water jet problem. Here, water jet problem is represented using a graph rather than a tree. Either a tree or a graph can be used for visualizing a problem. For 8 puzzle, we know the initial state and goal state. Initial state can have different forms, but there is only one goal state for 8 puzzle problem. For 8 puzzle, this is the state space representation, and if you check, you can see that one solution path is highlighted, and you can easily draw state space representation of 8 puzzle and also for water jet problem. It is not easy to show the state space representation of chess game, so that is not shown here. You can try this problem as homework. Draw state space representation for 8 puzzle problem. A particular initial state is given. Thank you.